learning today. If you see this, it means you probably saw it soon after the live, and I haven't edited yet, but usually I clip out the beginning stuff where I'm just like futzing around. So you can probably find a chapter or skim forward to when I actually start. You'll see like it'll look like a browser page and all that kind of stuff. How is everyone? Um, Erlang is not the biggest topic. I can tell by the views on these videos. Like, not everyone's into Erlang. I get it. Too bad, like, I'm not into, like, just doing the really popular stuff. It would work out better in terms of, like, getting more views on these videos. But the thing is, I actually really like Rust and I want to play with Zig and, these kind of hip languages. So but, everything I've ever liked, Game of Thrones, reading it like in the books first, like everyone eventually likes it. So one day you all gonna like Erlang. I I'm calling it now. I should set up some of my windows so I can actually see chat. So how are you guys doing? Let's see, how am I doing? I have to start thinking about it's Monday, so it's like the beginning of a week. My Saturday was really screwed up. I like couldn't get into a good mood. It was just like I was in this horrid mood, as if I think I was like everything. I was hangry. I don't know, like everything was bad. I went out, I snapped at my girlfriend a couple of times. And I never snap at her. She's like the nicest person in the world. So like why am I snapping at her? I was so like just pissy the whole time. I was miserable to be with? Then I got food. I felt a little bit better. By then it was like 3 p.m., 4 p.m. Hey there, Druv. How are you doing? It's been a while since I've seen you. And then we had some Japanese food. I think we had to do shopping. Like she had to buy some stuff. She's doing a lot of knitting. I'm going to show her stuff. Look how amazing this. She gets, I'm sure she has ADHD also. Look how amazing this looks. She crocheted this herself. Isn't that amazing? It's truly like, I forget the name of this Pokemon, but she's fucking adorable. She also made this just now. She's gonna hate me if she sees I'm doing this. Oh my god. Look how cute that is. It's gonna be on our Christmas tree. Fuck, it's so cute. I love it. It's a penguin with headsets and a Christmas sweater. How cool is that? Like, she makes things with her hands. That's great. I just did a talk where I talked about how I don't do things with my hands. I hope they published a video. I want to post it. But yeah, I type things and I think about things. That's more my style. So yeah, it's Monday. Sunday, I think we just chilled out. I did a stream on Erlang again. Yeah, so I think today I have to work. But before working, I'm going to do some of this Erlang stuff. For those of you who don't know what Erlang is, it's a computer language made in 1986 or so by Ericsson, which is a Swedish telephony company. They made like phones and they had their network. I don't know where they are now. Um, and it was just to basically run like very parallel systems. So that ended up creating the Beam virtual machine, which Erlang runs on top of. And they've built Elixir on top of it. You probably heard of Gleam also. Um, and I've been using it with Elixir. but now I want to get like lower in the stack and understand like where it came from. Also, some things are only available in through Erlang. Very few things, but I think it's useful to know. So there we go. That's why I'm like checking out Erlang. Also, I bought a t-shirt for Erlang and I really like it. So I can't like wear the t-shirt if I don't know it at all, right? That's just like a little bit lame. So we don't want to do that. All right, let's get started. Let's do this. As usual, we're going to like probably do a little bit of review. So, we're in our Erlang project. We can run Erl. I know we've done this 100 times with the list comprehensions. I won't do it again, but bit syntax is still a little bit annoying for me. I remember now, like, you put like the base in front of the number and then you type in the number. This will be 15. It outputs it in decimal. So FF is 255 and 01 would be 1. And it's still 1 even if we're in base 2. So there's that. And then we put things, if we want to put them in like a binary syntax, I'm not sure. It looks like this. So we can put a number in here like base 201 and that prints 1. And we can put F in here and it'll be 15. FF is Y. But now we can tell like how big the space is. So if we tell it the space, let's do F, right? So let's just do 1 because it's super easy. If we tell it the space is 2 bits long, then I think we do 2 here. If we make it 10 bits long, it's this. Because each number is 8 bits. Each comma separated number in this bits syntax is 8 bits long. So once we say it is 24 bits, you'll have 3 numbers, 0, 0, 1, right? This number that you put in here goes all the way to the right. So if I make it a longer number, like FF, then, oh, then I have like, the FF's going to take 1 byte, so it takes up this whole number. But then the fact that I put a 1 pushes it to the left. So we have the 15 from the first F here, then we have the 15 here, but then we have the 1 also. So that's what, oh, the other thing is we can pull numbers out of the binary syntax, the bit syntax. I think that's really simple to do. Like we can do red. Let's give it red, green, blue. And here we'll give it a real like red, green, blue. Here we go. That's like a real number, right? So now you can see 255, 0, 16. This 1 is a 16 in hexadecimal. Yeah, Findus, I'm starting early because I want to work today too. So just, I'm locked in, gonna do this, then work. Um, so that's how we pull numbers out. Does this make sense, everyone? I did a whole stream on this. Just look for the one with bit syntax and binary comprehensions. So this pulls out stuff. By default, they're 8 bits. So that's why we didn't have to do this. But it's the same thing. I think it would sort of be an error to do this because this side is bigger than this side now, right? Let's see, binary comprehensions. This one was annoying for me because I remember we basically are making binary comprehension with this surrounding it. Because remember, this is what list comprehensions look like, right? Like, There we have a list comprehension. It's building a list, and obviously this is the common example. 2 times n, it basically takes the 1, 2, 3, multiplies it by 2, and then you have 2, 4, 6. So I think what we are doing is we switch this into like this, right? And in here, it's like so obvious whenever I look at it, but whenever I try, it just makes no sense. Um, maybe we like try to do this. There we go. Yeah, that's what it is. Now, that's the super simple version of it. It basically takes a list and turns it into a binary syntax, bit syntax comprehension, right? So this becomes the 1n, it just adds to it the numbers you have here. But usually you're going to give it like red, green, blue values or something like that, you know, some kind of um, list, let's say tuple here. And if it's colors, then our colors might look like 210, you know, 4 for our, we're just thinking RGB here, right? Um, and we might have 10 comma 100 comma 1, it's another color. And we have like 100 100 100 as a third color. Here we got 3 colors. Now we don't want to make it just n. We want to break it up into RGB. So we do RGB. And now we can like turn it into the binary syntax RGB. So this one breaks it up into the RGB individual variables. Yeah, Clono Pin Commander Erlang is a programming language. It is the basis of Beam, the virtual machine, and Elixir is built on top of Beam, so is Gleam, and they're used in companies like WhatsApp and Discord for the highly scalable aspect and parallel aspect. If you want to do like parallel programming, it's a very good system to learn, and especially like reliable and fallback systems and all that kind of stuff. So we pulled out the RGB values and then we added them into the bit syntax. So now we have one stream of binary numbers that match the colors that we had earlier. It's a functional programming language also, just to be clear. Um, so if you're into functional programming languages, it's a good one to know. And then we learn modules. Modules are very straightforward. You'll see it in action. Syntax and functions, we did pattern matching. Okay, so one thing I had like from yesterday that really like helped me understand things better was that um, when we have these if statements we learned about like this in Elixir, this is a cond statement. So like in Elixir, you would have cond some kind of like thing do, and then like you would have these statements like x is equal to 3, and then you would, you know, operate here, and true do the is like the fallback case. That's exactly what if statements are in Erlang. These are basically cons. Um, However, what was I going to say? They're basically con statements. I don't think there's any however. That's it. So if you think about them that way, then it might help if you know Elixir. That's why I couldn't call a function inside of an if statement here. I wanted to call like whatever member, something like that. And that just doesn't work because the if clause itself cannot call functions. It can only have stuff that you normally see in guards. So very basic stuff. All right. I think we're going to be using patterns and if statements and what was the other one? Case statements all the time. So I don't think we need to review it. Let's go straight into dynamic strong typing and see what this section is about. All right, let's go. Types or lack thereof, dynamic strong typing. As you might have noticed when typing in examples from starting out for real, and then modules and functions from modules, and syntax in functions, we never needed to write the type of a variable or the type of a function. Right? We never said like, we never declared this thing as an integer or whatever. When pattern matching, the code we had written didn't have to know what it would be matched against. The tuple xy could be matched with Atom 1, 2, 3, as well as a string binary stuff. Right. So we remember like we can match x is equal to 4, right? Whoops. X is equal to 4. I've forgotten everything. In Erlang, oops, why am I switching my keyboard? In Erlang, variables are all capitals. So now x is 4, right? But if x were, this clears everything. Now, if I have a list, 1, 2, 3, remember that can match to head, tail, right? And now h is going to be 1, oops, 1, and tail is going to be the list 2, 3. And in fact, we even saw something where we matched it even further. J, right? Oops. Why didn't this work? I think because I changed, oh, because I'm changing the value of tail. That's why. So when I clear it, now it works. So now J is going to be the second one, so it's 2, and tail is just going to be the list with one element 3. And if we did it one more time, then tail would become the empty list. So what this is saying is it doesn't know what the type is for any of this stuff. In fact, we can start mixing up some of these types here, and we can say something like last element. And this is a string. And now tail is going to be the list with a string, right? It doesn't care that it's a string or anything. It can hold anything. All right. I think we read this, right. When it didn't work, an error was thrown in your face, but only once you ran the code. This is because Erlang is dynamically typed. Every error is caught at runtime, and the compiler won't always yell at you when compiling modules, where things may result in failure, like starting out llama plus 5. I don't remember this llama plus 5. Do you guys? Doesn't matter. One classic friction point between proponents of static and dynamic typing has to do with the safety of the software being written. Okay, this is like talking about like programming stuff. I just want to learn the language. It's saying that you don't really need static typing to be reliable. And yeah, I mean it's saying that it works, right? Like that's fine. Erlang is also strongly typed. A weakly typed language would do implicit type conversions between terms. If Erlang were to be weakly typed, we could possibly do the operation 6 equals 5 plus 1, when in practice the exception for bad arguments will be thrown. Yeah, so we can't do 5 plus 1. I think like what? In TypeScript you can, right? Or maybe Python. Type conversion. So we have functions that can convert types. Looks like there's an Erlang. Well, everything in Erlang they said should be in the imported automatically, so I shouldn't need to type it. Let's see if we're right. There we go. Yeah, we're right. Um, so this will turn it to an integer, and now I can do 5 plus this. And there we go, 59. And I'm guessing this will throw an exception if I give it like, yeah, if I give it a character or a string. And looks like it handles floating point numbers in the sense that it throws an exception. But there's a list to float. Interesting. It's kind of interesting that they call it list, right? Because to you, it doesn't really look like a list, right? Um, but this is a list. Let's look up what the number 1 is. 1. Wait, how do I know what number this is though? The hell? How do I read this? Is this binary? But this is just 1. This is not a very useful chart for me. Maybe I should. What? Oh, here's the top bits. Is that right? One, 100. So let's try this. 100, 0001. Oh yeah, that's right. 65 is A. So that means the number 1 is 0110001. Okay, so it's 49. Let's try, if we make a list with the number 65, this should just print the letter A. Yeah, there we go. And now we put in 49 comma A, comma, this should be 1A. There we go. All right, so the reason why this is called list, well, let's give it an actual like, so 50 would be 12, right? Yeah, 12. So now we do list to integer, and we give it this list, and it turns it to 12. You see, the number 12. And now I can do plus 1. And this makes more sense why it's called list to integer, because we're giving it a list. How funny, right? But obviously, this is the same as typing in 12. And to further show that we can do this, we can pattern match on it. And it's the same. Or we can use the equality operator function, and they're the same. I am very pedantic here, huh? Sorry. So we have list to float, atom to list. So basically, anytime you see list, it's kind of like saying string, right? Atom to string, so we can do atom to string, some atom, atom to list. There we go, some atom. List to bit string. Aha. So it turns our normal string, which is a list, into a bit string. So these things are called bit strings. We just have to remember to call them bit strings, the things in the angle brackets. Bit strings are sometimes faster to use. We learned that, but they're less flexible. You can't like manipulate them in the same way and have all the helper functions around them. Um, Here we're hitting on a language wart here because the scheme type to type is used every time a new type is added to the language. A whole lot of conversion BIFs, built-in functions, need to be added. Here's the whole list already there. That's a lot of conversion functions. We see most, if not all, of these types through this book, although we probably won't need all of these functions. So here's a bunch of guards. Remember when we were doing like functions here, like isList? So we can make a function foo that takes in L, and we can say when isList. Sorry, I'm so used to typing in lowercase. IsList. Why am I putting this? IO format foo got list p n. L. And then we have to export foo, which takes in one parameter. There we go. Oh, it did not like that because I put it in the wrong place. There we go. So here we defined a function foo that takes in a list, and it won't take anything else, right? So here now, when I go into Erl, I can compile new. Isn't it called new greet? Yeah. Now, if I pass in a list, it says foo got list 1, 2, 3. But if I pass in something else, it's going to say I can't find the function. What? Oh, because a string is a list. Yikes. All right, there. No function clause matching. So we can now add a new foo when is integer, and then we can do IO format foo got some number. This is not efficient code, but you get it. And now here, I think we do comma. Is that right? When you, no, let's see. Semicolon. Semicolon for function clauses. There we go. So all the other ones have semicolons, meaning they continue. And then you have a dot at the end. I think semicolon is basically like or else. So the idea is like it could match this, or it could match this, or it could match this. I think that's the idea. And now if I compile again and I give it a list, it says got list, but I can also just give it a number now. And it says got some number. So you can see how like we can use these guards to determine which of the functions we're going to be using. Test type BIFs constitute more than half the functions, and then there's other built-in functions. We'll learn about them later. It may seem like Erlang data structures are relatively limited, but lists and tuples are usually enough to build other complex structures without worrying about anything. Yeah, you look at lists, for example, everything's lists, right? And you can still get by. As an example, the basic node of a binary tree could be represented as node value left, right, where left and right are either similar nodes or empty tuples. I could also represent myself as, here's a tuple. It's a two-element tuple, but the second element is another tuple that has a name as the first, and then it looks like, oh no, wait, person name. So the second element is a tuple. I see they're all basically, they're all tuples afterwards, but it's a two tuple. It has a keyword, an atom, that's like basically the keyword, and then the value. So it's kind of like a map. So here's the key, and then you have all the various values here. And the values themselves can be lists or anything, I guess. So there we go. Handsome, smart, honest, objective. Yeah, all good qualities. False, liar. Skills, programming, bass guitar, underwater breakdancing. Okay, I'm going to skip some of this stuff here. For type junkies, this section is meant to be read by programmers who cannot live without a static type system for one reason or another. I used to be really like in this kind of mode where I really miss static typing in Elixir. The funny thing is they're starting to like build more type checking in Elixir now. But I found like I didn't really need it. With dialyzer and also guards, it covers most of it. There's still places that I don't like, but what can you do? Like callback functions, knowing whether or not a module you pass in actually implements the function, it's not always clear. It will include a little bit more advanced theory, and everything may not be understood by everyone. I will briefly describe tools used to do static type analysis in Erlang, defining custom types and getting more type safety that way. These tools will be described for anyone to understand much later in the book, given that it is not necessary to use any of them to write readable, reliable Erlang programs. Because we'll show them later, I'll give very little details about installing, running them, etc. Through the years, there were some attempts to build type system on top of Erlang. One such attempt happened in '97, conducted by Simon Marlowe, one of the lead developers of the Glasgow Haskell compiler. Gotta do more Haskell. And Philip Wadler, who worked on Haskell's design and has contributed to the theory behind monads. Joe Armstrong later commented on this paper. One day, Phil phoned me up and announced that A, Erlang needed a type system, B, he had written a small prototype of a type system, and C, he had 1 year's sabbatical and was going to write a type system for Erlang, and were we interested? Answer, yes. Phil Wadler and Simon Marlowe worked on a type system for over a year, and the results were published in 20. The results of the project were somewhat disappointing. To start with, only a subset of the language was type checkable, the major omission being the lack of process types and the type checking inter-process messages. Yeah, I mean, that's one of the benefits of OTP is like you can send any message, and once you type check them, I wonder just like how that all kind of ends up working. Processes and messages both being one of the core features of Erlang, it may explain why the system was never added to the language. Other attempts at typing Erlang failed. The efforts of the Hype project, attempts to make Erlang's performance much better, produced Dialyzer, a static analysis tool still in use today with its very own type inference mechanism. This I've used with Elixir. It works pretty well, except sometimes the errors are very, very cryptic. The type system that came out of it is based on success typings, a concept different from Hindley, Milner, or soft typing type systems. Success types are simple in concept. The type inference will not try to find the exact type of every expression, but it will guarantee that the types it infers are right and the type errors it finds are really errors. Best example would come from the implementation of the function AND, which will usually take two Boolean values and return true if they're both true, false otherwise. In Haskell's type system, this would be written AND bool bool bool. Yeah, so this is like with type currying, function curry with currying. So it takes in bool as a parameter, kind of a second parameter bool, and returns a bool. If the AND function had to be implemented in Erlang, it could be done the following way. Okay, yeah, this is saying if anything's false, it doesn't matter what the other one is. Or if the second parameter is false, it doesn't matter what the first parameter is. And true, true is true. I'm confused though. Why wouldn't you just write it like true, true is true, and then you just say whatever else is false? Doesn't that work? Oh, something's wrong. Oh, because of the word. Does this not work? Let's try. What am I missing? True, true, true. True, false, false. False, false, false. False, true. False. Doesn't it seem easier? You don't need to write as much code. Under success typing, the inferred type of the function would be and underscore underscore bool, where underscore means anything. The reason for this is simple. When running an Erlang program and calling this function with the arguments false and 42, the result would still be false, and the use of underscore wildcard in pattern matching made it that in practice. Any argument can be passed as long as one of them is false. Yeah, it's kind of what I just said, right? ML types would have thrown a fit and its users had a heart attack if you had called the function this way, not Erlang. It may make more sense to you if you decide to read the paper on implementation of success types. Okay. What is this? This is more stuff that I don't think we need to look into. Dialyzer will complain only when code will break other code, and if it does, it'll usually be right. It will complain about more stuff too, like clauses that will never match or general discrepancies. Polymorphic data types are also possible to write and analyze with Dialyzer. The head function could be annotated with spec and be analyzed correctly. All right, don't drink too much Kool-Aid. Some of the things you can't expect Dialyzer and Typer to do is type classes with constructors, first order types, and recursive types. The type of Erlang are only annotations without effects or restrictions on actual compiling unless you enforce them yourself. Okay, so it's saying don't rely on it. It won't catch everything. Well, we covered it. We covered the chapter in only 40 minutes. Then it looks like we're going to be doing some recursive functions. This looks like a long section. Should we do a little bit? Um, so they're saying something about for and while. but it's a functional language. So let's see here. Factorial function is a good example. We want to use it. It's basically like if you want to know the factorial of n, it is 1 times 2 times 3 all the way up to n. Or you start with n and you go down to 1. So 3 factorial, 3 times 2 times 1 is equal to 6, right? So let's try to remember. Let's try, how does this work? Module, and we like put it in parens maybe, and we write like recursion. And let's save this and call it recursion.url. Maybe this has to be, let's see here, module new greet. Why is it not happy? Because I typed it in wrong. It needs to match the file name. And now we can make a function called fact, which if it takes in 1, we can just do it this way, right? Then it's going to return 1. Otherwise, fact of n is equal to n times fact n minus 1. And then what was the export all thing? It was in here. Ah, here it is. Export all. Do I need to want? Oh, doesn't like this? Like this? Ah, come on. Oh, it's part of the compile options. I see. There's no way for me to like put it in here. I guess not. So we do recursion, comma, was it export all? Okay, now I can do recursion, fact 1 gives me 1, and 3 gives me 6, and 4 gives me 24. That seems right. Yeah, and then they kind of made it a little bit nicer with guards. I was gonna do like this. Whoops. I was gonna write n is less than or equal to 1. This way, like, If it was 0, it would still say 1. Yeah, that still works, or any negative number. I don't know if that's right or not, but um, length. I think we actually wrote length before, didn't we? Here somewhere. No, I wrote member. So we can write length. Um, length, it takes in a list, I assume. Yep. And if the list is empty, then we return 0. Otherwise, we return, I guess, 1 plus. Let's break this up into head and tail. All right, so I know that an empty list is 0. Otherwise, it's going to be 1 greater than the length of the rest of it. Why is it not happy here? Oh, because I didn't know what length. Okay, there we go. Variable h is not used. Very good point. And now I can do recursion, my length, and give it a list. This should be 3, right? And this should be, whoops. This should be 1, and this should be 0. Okay. Yeah, it looks like very similar to our solution. In general, it's nice to put the recursive case at the end in case it supports tail end recursion. Oh, here it talks about tail end recursion. What is this saying? It's using an accumulator. All right, let's keep going. Just to get into the habit, let's write some more recursive functions. The first one we'll write is duplicate2. This function takes an integer as its first parameter and then any other term as its second parameter. It then creates a list of as many copies of the term as specified by the integer. Like before, thinking of the base case first. So let's try to write duplicate. So duplicate takes in a number, did it say? Like, we know 0 and we pass in any term is just going to be like the empty list, right? We know that much. We also know that, just this is kind of a silly one, but we also know that if it's one item, then it would kind of look like this, right? So otherwise, duplicate n, t is going to look like um, putting t in the front, followed by whatever duplicate, oops, whatever duplicate n minus 1 comma t returns, right? So we put t in the front of a list, and then we're going to call duplicate, but subtract so that we eventually get to our base case. We don't actually need this one. So let's see if this compiles. T is unused. Not here. Okay. Recursion duplicate, and we tell it the number of times and some term. We'll use like the term A. So we have a list with A. We give it 0, we get an empty list. We say 10, we have 10 A's. The term could also be a list, tuple. Oh! And we get 10 of these tuples. Hi, Himvault. Sorry, I wasn't like following. I guess I kind of zoned out. How long ago was that? 6 minutes ago? Is the stream's name checkout on purpose? It's named this on both platforms. I had no idea. What? Oh, check out. No, I had no idea. I will fix it. I'm watching at work while writing Groovy code, Jenkins file. I don't know. I've heard of Groovy. I don't know what it is. JVM? Oh, so it's like Ruby and Smalltalk. Smalltalk. Oh, it has AST transformation, so that's interesting. Groovy beans. I think I have PTSD. Cool. I'll have to check it out someday. So we wrote duplicate, right? Yeah, I think the same thing here. They did add like when n is greater than or equal to greater than 0. It's not really required, right? Because this is going to come first. Now they're turning it into a tail recursive one. Because here it's not tail recursive because it has to keep track of this term thing. So it has to descend, return, and then concatenate the two together. Here you're keeping an accumulator here. So basically it begins with an empty list. And if it's 0, then you return the list. Otherwise, you just return n minus 1 term list. Got it. Yeah, so we're putting the term, so we're building it as we're going in this case. You see, like, we're basically taking the term and then adding it to the list here. The list started off as empty, and then we keep adding to it. So we're building in this recursive loop. I guess it's a lot like running a reduce. Um, does this exist? I want to change the subject a little bit here by drawing a parallel between tail recursion and a while loop. Our, our tail duplicate function has all the usual parts of a while loop. If we were to imagine a while loop, I see, so this doesn't actually exist, but it's saying that all the pieces are here. So here's reverse. I'm not gonna write all of these. I know I can write them, so not too interesting here. Sublist takes an L and an integer n, returns the n first elements of the list. Yeah, that's not too interesting either. So go ahead and try these out. You should have everything you need to do them. Zip is basically going to join these two things together. And then next session we'll do quicksort. That'll be fun. And finish the rest of this chapter. So we'll stop at quicksort. I think I'm gonna like switch over to doing some work. I will stream it up until the point that I stop, I guess. But I'm gonna take a break first. How you guys doing? Who's here? There's a couple of you. Starting work is always like a hard shift. It's like it takes a little bit of mental preparation to do. I don't really know any. I'm so bad at like DevOps, like, so I don't know if Groovy's done mostly for DevOps, but I just don't know. I'm just really bad at it. All right, I'm gonna make more coffee and then I'm gonna start work, okay? I'll be right back.